Hello listeners, I am Dr. Kavita and today in this video I am going to discuss about tuned circuit oscillators. What are tuned circuit oscillators? The circuits which produces oscillations with the help of tuning circuits are called tuned circuit oscillators. And this tuning circuit consists of inductor L and capacitor C. These are also known as LC oscillators, resonant circuit oscillators or tank circuit oscillators. I am going to discuss about three important tuned oscillators one by one. First one is tuned collector common emitter oscillator. It uses inductive feedback and that is from collector of a transistor to the base. The tank circuit or LC circuit is in the collector circuit of the transistor. The next is Hartley oscillator. It uses inductive feedback and Colpitz's oscillator uses capacitive feedback. The different type of oscillators have same functions that they generate continuous undamped output. But the main difference between the oscillators lies in the method by which the energy is applied to the tank circuit to meet up the losses. First, I will discuss about tuned collector common emitter oscillator. This is circuit diagram of tuned collector common emitter oscillator. You can see various resistances, capacitors, inductor coil, transistor and power supply are using in this circuit. Now, why tuned collector? Tuned collector means the tank circuit is connected at the collector, and in this circuit we can see the inductor coil L and capacitor C. These two components form the tank circuit and the tank circuit is at the collector end. And next is common emitter oscillator. So the transistor used here in the form of its common emitter configuration. So we are using here common emitter transistor amplifier. Now the coil L1. This coil L1 is connected between base and emitter terminal of the transistor. And this coil L1 is connected with the coil L in such a way that mutual induction took place between coil L and L1. The output is drawn across this coil L2. Now we are using voltage divider biasing circuit. Voltage divider biasing circuit is actually consists of this R1 and R2 resistances. So why we used voltage divider biasing circuit instead of simple biasing circuit? The important role of this voltage divider biasing circuit is that it makes the transistor voltage gain independent of its beta value. इसको कैसे समझेंगे? ट्रांजिस्टर हमारे पास एक इलेक्ट्रॉनिक डिवाइस है जिसकी यूनिक प्रॉपर्टी होती है उसकी बीटा वैल्यू. तो हर ट्रांजिस्टर के पास उसकी एक बीटा वैल्यू होती है. अगर हम वोल्टेज डिवाइडर सर्किट यूज करते हैं, इन दैट केस वी विल मेक द वोल्टेज गेन इंडिपेंडेंट ऑफ दिस बीटा वैल्यू. इट मीन्स we can make the voltage gain independent of a particular transistor. Then we can replace one transistor with another transistor without facing any problem in the circuit. So this is beauty of this voltage divider biasing circuit. Next, resistance R1, R2 and RV provides DC biasing to the transistor. And now capacitor C prime and CE. These are actually bypass capacitors. Bypass capacitors means these actually bypass the AC signal or they provide low resistance path to the AC signal. अगर हम कहें कि हमारे सर्किट में CE कनेक्ट नहीं होता तो क्या होता? So if there is no CE in the circuit, then the AC signal or AC voltage drop across RE will affect the input signal. Similarly, if in our circuit there is no C prime, then what happen? If there is no C prime, in that case the feedback voltage included in the secondary coil L1 of transistor, because the voltage across this L1 coil is actually applied at base and emitter terminal of the transistor. So this feedback voltage included in the secondary coil L1 will not go to input of transistor, as some voltage will drop across resistance R2. That's why this C prime capacitor will provide a low resistance path to this AC voltage, and that's why there will be no drop across R2. So this is introduction of all the components connected in the circuit. Now we will discuss working of this circuit. When we switch on the key, then this power supply is connected in the circuit. Means the transistor is properly biased. With the biasing of transistor, there is flow of current, and the collector current starts charging of capacitor C. When the capacitor C is fully charged, it discharges through the inductor coil L, and the tank circuit operation will take place. It means the energy stored in the capacitor C in the form of electrostatic energy gets converted into electromagnetic energy, and that will store in the inductor L. Now we know that the coil L1 is coupled with coil L in such a way that a mutual induced EMF will generated across this coil L1, and the induced EMF across this coil L1 have same frequency as that of this tank circuit, but the amplitude depends upon the coupling between coil L and L1, and also on the number of turns in coil L and L1. Now the coil L1 is connected between base and emitter of the transistor. So the signal which is applied at base of transistor will be amplified, and this amplified signal will fed back again to the tank circuit. In this way, the losses in tank circuit are compensated to get undamped oscillations, and in this way this closed loop repeated again and again produces undamped and sustained oscillations. Now to get the undamped or sustained oscillation, the most important point is that the voltage which is fed from this coil L to L1 will be in same phase as that of the previous input signal of the amplifier. It means there must be positive feedback. So how in this circuit there is positive feedback? Now we will understand this. Here the feedback is just to overcome the losses in the tank circuit. Now we know that if at base of transistor there is a signal in this way, then this transistor is in common emitter amplifier form. So the voltage appear on the collector will be 180 degree out of phase from this base signal. So we will get this signal at the collector, and we can see the signal is 180 degree phase difference with that of the base signal. This signal is supplied to the tank circuit. So the induced EMF or the signal induced across L will be in this way. There will be no phase change. It will directly induced in the inductor coil L. Now this L and L1 are connected in such a way that during this mutual induction there must be 180 degree phase difference. Only then we can nullify this phase difference. It means when the signal is induced from coil L to L1, there must be 180 degree phase difference. So the winding of coil L1 through coil L will be made in such a way that during mutual induction there is 180 degree phase difference between the signals, and with this 180 degree phase difference we can say 180 degree phase difference from base to collector and 180 degree phase difference from coil L to L1. So finally, when the signal will reach at the base of transistor, it will in the same phase with that of the previous signal. So there is 360 degree or 0 degree phase difference, means there is positive feedback at the input of amplifier, and in this way we can get sustained or undamped oscillations. The oscillations finally get across inductor L2 have the frequency 1 upon 2 pi square root of 1 by LC. Here L is inductance of this coil and C is capacitance of this capacitor. You can see that there is arrow on this capacitor. This arrow means this capacitor is with variable capacitance, and the capacitance may be changed intentionally with the help of either mechanical effort or by electronically. And these tuned collector, common emitter oscillator are very important, and they are actually involved in the local oscillator of a radio. So this is end of our today's video. I hope you get the idea about tuned collector, common emitter oscillator. Please put your comment and your suggestions in the comment box. Thank you.